Hi guys, Mathemagic here. Today's video is going to be a bit different. We're going to be exploring some maths in Minecraft. Just a heads up before we get into it, my laptop is not very powerful, so please excuse the at times rather choppy gameplay. Let's get right into it. So our first example here is what I like to call the sand launcher. So it's comprised of four main parts. So we've got this magazine of sand here, we've got our horizontal launcher, we've got our vertical launcher, and then we've got our clock here to time it all, to periodically send the sand flying. So we've got a nice little x-axis here, and I'm going to leave this running as time-lapse, and we're going to see what shape this sand, which is affected by gravity in Minecraft, and we'll see what shape that makes. Okay, we're out of sand, but you can pretty much see the picture. I'll just turn this off. So we've pretty much got what we know in maths as a parabola. That is y equals x squared. It is obviously being transformed a bit here, but we do have that rough shape that anything in the free fall of gravity will form as a path, and this sand here has clearly in projectile motion has formed a parabola. Now you might notice that this parabola is slightly lopsided to the left. It's not much, but it's just these two blocks. That is we are limited to a one block basis. Of course, parabolas can go between one block or one unit on the graph, however you want to call it. But anyway, that is why it is not a perfect parabola. But let's get on to the next example. Okay, on to our second example. This time we're going to be using or exploring momentum in Minecraft. So how's it going to work? We're going to put a cart down here going as fast as possible, and we're going to have a stationary cart here that is going to collide with. If Minecraft has its calculations correct, this cart that's flying down here should stop, have a dead stop, and this cart should fly along at the same speed as this cart was, as momentum is always conserved. Now I've got these two timers here that I'm going to be timing the how long it takes for the cart to go across here, and if the time is the same for our test run compared with the collision, then we know that momentum is indeed conserved. This is notwithstanding elastic and inelastic collisions, by the way. So let's get our cart going and my timer ready. We're going to release the cart here, and I'm going to watch the diamonds. So I got a time of 0.53 seconds. So if we put a cart here, what time are we going to get with the collision? So I got a time of 0.46 seconds for that cart. Now that doesn't mean that momentum isn't conserved. In fact, I think that you'll realize that my timing and the margin of error is just too great to not consider that 0.46 time. So yes, momentum is conserved in Minecraft. The time after the collision was the same as the time as if the cart kept going. So on to the next example. Okay, for this example, we're going to be measuring how much force is required to kill a sheep with a free-falling anvil. So if we put our lucky sheep in here, we're going to start getting some data, and we'll go over to some paper and pen to figure this out a bit later. We'll just collect the data now. So these are some lucky escapees from previous tests. So 2 meters, let's check. The sheep survives. Let's go 3 meters. Nope, that didn't do it. 4 meters. Nope. Let's go 5 meters. And that's what it takes to kill a sheep in Minecraft, is 5 meters of an anvil falling down. And we'll go over and we'll do some calculations to figure out the force required to kill this unfortunate animal. Okay, so I've gone ahead and done some preliminary calculations and written down all the data here for figuring out our force required to kill a sheep in Minecraft from a free falling anvil. So I've gone ahead and calculated the velocity that the anvil will be at the top of the sheep, assuming that this sheep provides constant acceleration. We can then figure out how fast that anvil was indeed decelerating. So let's do that. So we know v is going to be equal to 0, the final velocity, when it reaches the bottom of that pit that we saw. Initial is going to be this squared, 15.84 squared, plus 2 times a, we're solving for a, times 1. We're going to assume that this sheep is indeed 1 block tall. So we're going to get 15.84 squared, subtract that, so we're going to get negative 250.91 equals 2a, and then divide that by 2. We're just going to get that is a huge acceleration, negative 125.45 meters per second squared. And from here we can actually calculate the force that was exerted to provide this acceleration. So we know force equals ma, so force. Mass of the anvil as well. Huge shout out to guys on Reddit who figured this out. I will put their links in the description as well. So going to be 3,254 kilograms multiplied by 125.45. We don't need to put the negative, we know what direction this is going to be in. So if we multiply that by 3,254, we're going to get a force of 408,223 newtons. So the force required to kill a sheep in Minecraft from a free falling anvil is going to be 408 kilonewtons, and that is a heck of a lot of force. Okay, that's it for this video, guys. Thanks very much for watching. We definitely had some fun doing some maths in Minecraft today. I'll see you all later.